Hello everyone, today we're going to look at the D flip-flop, known as the delay flip-flop or the data flip-flop. This data flip-flop, as I will probably refer to it as, can hold one bit of data. Now, we can see here that right now there is a Q and a not Q. Generally, I look at the Q as the thing I care about, the output, and the not Q as the opposite of the thing I care about. Um, In certain instances, you might care to know what the opposite is, and that functionality is available. Anyway, let's add a voltage source, and you're probably thinking, oh, this is great. The minute we apply power, we should get a 1. Well, nothing happened, but is that because the simulator's not running? Maybe. Let's find out. No. If anything, it says the opposite. Is that what we're expecting? If we take this away, it still says it's the opposite. So how do we get the Q to light up? Well, that's where the magic of the clock comes in. If you look at here, we have clocks. And a clock is quite simply a power source that turns on and off in a timely manner. So we can see we go high and low, and it's doing that in a timely manner. If we connect it to this little clock pin, it sets it, and if we take this away, all of a sudden now it will unset it. But let's slow this down a little bit. This clock is, I know it's blazing fast. Blazing fast. We don't want anything moving quite that quick on our screen. So we're going to manually supply power because we can do that in a circuit simulator. So let's say we take this away, and what happens? Well, it retains our 1. If I apply power here, nothing changes. So obviously the clock is where the magic is. Right now the clock would be 0. If we apply a 1 to the clock, we can see that it flipped. If we apply power here, run the simulator. Oh, sorry, that stopped the simulator. And we apply power, we can see that it triggers yet again. Now that was kind of interesting because it didn't do it automatically. So you're probably thinking, why? Well, the circuit is more than likely designed so that it actually will do it on the rising edge. So as the voltage goes from 0 to 1, that is what actually triggers it to run. And that would make sense because it's normally a clock. That could just be a feature of the simulator as well. If you actually had one of these chips in real life and you were to supply power and do what we just did, where you're manually doing this without adjusting this clock pin, it might actually flip on you. So obviously you have to actually buy the hardware in that case and play around with it, which I would encourage you to do. It's always fun to do. Now let's build one of these out of logic gates because we've been playing with logic gates in the last few videos. So we're going to work with NOR gates in this case. And what you're about to see is called an S-R Latch. I had an entire video on that. If you would like to see that video, I would encourage you to watch it. I personally think it's kind of entertaining and fun, but I made it. So if I didn't think that, that would be another issue. So let's see what happens here. Right now, we can see that we have power on this pin. So I would say this is, since we're not applying power anywhere else, I would say this is our not Q. And if I'm going to just add some wires here, a little bit longer. And now let's take this power source, and if we apply it here, all of a sudden it drops down to here. And if we apply it here, it goes up to here. So we can see that unlike this, where you apply power on the top and you get your output on the top, this is going to be the opposite. Wherever you apply your voltage to, it's going to be on the opposite leg, which is fine. There's no issues with that. We in fact will add labels to sort of illustrate that. I'm just going to say not Q, And then I'll add some text here and call this one Q. All right, so this is great. But as you know, we are, oh, and D. Let's call this D. This is actually not really D, and you'll see why in a second. And that second is now up. And the thing is, this does not work off of a clock. Yes, you can supply power to the pins and it remembers what you did, but we want a clock involved because in an actual computer, the clock is what makes everything go forward. It's almost like a pump where it's pumping the data through the circuits. So we need to figure out how can we add another input that will trigger this to run. Well, the other thing we need to do is we need to figure out how to trigger the reset pin. Right now, we need power on these pins. So what we're going to do is add an inverter, and we're going to put these two together. Put that there. Put this here. So now if we put this on here, these wires are not long enough. We can see that power comes through here, and yep, that's what we're expecting. Now if we take it away, it will instantly reset. And believe it or not, this is the first step, and this is a good step. But we need to add that level, that clock level that we talked about. So what we're going to do is actually add in some ands. And right here. And this is just kind of a rudimentary thing. That's the fun thing about these circuit simulators is you can kind of experiment with different things and see what you like and what you don't like. All right. Now, obviously, the other pin on the AND is going to be the clock. So again, just like when this had power going to the pin, it would switch. We're going to work the same way with our little circuit here. So this will be our clock, and this will be our D. All right, so let's apply power. Nothing happens. If we take it away, nothing happens. And the simulator's running because it turns red when it's not running. So we know it's not that the simulator is frozen. So let's try it with applying voltage to our clock. Let's add clock pin. All of a sudden now the clock is high. It has a 1. And we can see that not Q is lit up, which makes sense because we're not applying anything to D. We apply it to D. Now it switches. It goes to our Q. Take that away, and it remains at Q. We take this away, it remains at Q. We just fire the clock again, and it resets because there was nothing here when the clock was high. And we have just duplicated the functionality of this circuit. So this integrated circuit integrates basically all this stuff into that, which is cool. That's the purpose of integrated circuits. Now, let's actually put a clock on here so we can see it flip on and off and actually see how it would work, because we went through all this hard work, right? Let's actually see. So the clock is firing, and D is high, so Q is high. We take that away, and all of a sudden now it is flipped over to our not Q. So there you go. This is a D flip-flop. We have started with the actual chip basically built into this program, and now we have gone through and created our own out of an S-R latch and logic gates. So this is some of the fun you can have with logic gates. I hope you found this video entertaining, enjoyable, and all those other fun things. Please do consider subscribing. It does help the channel. And we look forward to seeing you in the next video.